Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching and my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss two GATE questions which came in the year 2015 and 2018 respectively. So let me read out the question which is came in the 2015 and we will solve it. Then we will come to the question which came in the year 2018. Okay, which one of the following fields of an IP header is not modified by a typical IP router? They are talking that IP header. Already we have discussed about the IPv4 header format. Okay, and then they have given few fields. Which of the field is not modified? Okay, which of the field is not modified when it is going by a IP router? What is a IP router? Router is a device which consists of three layers. One is the physical layer, data link layer, and also the network layer. As in the network layer, IP protocol is a hot and popular protocol in the network layer. So that's why it is called as a IP router or IP based router or router. Okay. So now let me discuss about each field, whether it is modified at the router or intermediate node or not, we will discuss. Now come to the first field, time to live. The time to live will specify how much time the packet should be there in the network. Once the packet comes to the TTL value comes to the 0, then the packet has to be dropped from the network. Okay, even I have discussed when I am discussing about the frame format. Let me tell you with a small example. Source has kept the TTL value, time to live value is equal to 4 hops. And the source has forwarded this packet to the next router. So meaning is that it has passed in one hop, means the packet has been transferred from one hop to another hop. So it traveled one hop. So TTL value will be modified by 3. It will reduce by 1 and it will be modified to 3. So meaning is that TTL value is modified. Are you able to understand? So this is modified. Let me write it as M. So TTL value will be modified. Suppose this router is forwarding to another router. Again the packet has been traveled one hop. So TTL value will be updated to 2. Is it clear at this router? So every time the TTL value will be updated. Okay. So this field is modified. Now let me discuss about the length field. What is the length field? It is says the total length of the packet. Usually we have two lengths. One is the total length and header length in the IPv4 header format. Header length consists of 4 bits which will specify the length of the header, and total length consists of 16 bits which specifies the size of the header plus data. So this specifies the size of the header plus data, whereas this specifies only the size of the header. Are you able to understand? So now if you see that we were doing the fragmentation. When we will do the fragmentation, if source has a large size of the packet and the router outgoing link has the maximum MTU some 200 bytes. Okay. Now the whatever the source is sending, suppose let's take that it is 1000 bytes. Then what will happen? This 1000 bytes of a single packet, 1000 bytes of single datagram or a packet has been traversed to the router. Now router has to traverse to the destination, but however the router outgoing link has maximum MTU of 200 bytes. Then what it has to do? It cannot send the 1000 bytes of a packet at once. So you have to make it into multiple packets. Am I right? Or you have to divide this large packet into smaller packets so that the smaller packets can able to traverse using the router outgoing link. So this concept we'll call it as a fragmentation. When you are dividing into smaller packets, the total length of this one will specify 1000 bytes. Will you agree with me or not? The total length of this one will specify the 1000 bytes. But when you are making these packets into smaller packets such a way that each one will consist of 200 bytes only. Can you tell me what is the total length of this packet? It will be 200 bytes. Total length of this packet is 200 bytes. So again, you have to update the total length value in each divided packet or each fragment. So total length field is modified. Are you able to understand it or not? So this is modified, time to live is modified. Now we will see what is the use of checksum. Now what the checksum will do? Checksum will compute for the header only. When I was discussing about the IPv4 header format, I said that checksum will be computed only for the header. Why? Because whenever these values are modified in the header, again at the intermediate node or a router has to compute the checksum. If it is computing for the data also, it will be burden on the router. So that's why we are computing the checksum only for the header. As this time to live value and length value are modified, again the router has to compute the header checksum, so that the receiver, when it receives, it can verify whether it received the correct information or not. So obviously checksum also will be modified. Am I right? Now what is the next one? Source address. Source address is what? In IPv4 header, we will have two addresses. One is source address and destination address. Both are IP address of the source and the destination, which is a 32-bit, which will not be modified. Are you able to understand? The source IP address does not modified. So as they asked which is not modified, in this one checksum, time to live and length will be modified. However, the source address does not modify. So for this question, the right answer is B. I hope you have understood how I solved this question. Now let me discuss about the next question, which came in the year 2018. They have asked the match the following. Okay, they have given certain fields and the lengths. We need to find which one is matching with what. Okay. Now they are asking UDP port number. In UDP, we have two headers. One is the source port address and destination port address. Already I have discussed that port number is 16-bit. So it consists of 16-bit information. The length which is there in the port number, which will be a 16-bit information. So for P, the matching one is 4. Okay, now Ethernet MAC address. MAC address comes in the data link layer, which consists of physical address. Even we will call it as a MAC address, which is how many bits? 48 bits. So the matching for Q is 1. Are you able to understand it or not? In IPv6, the number of bits will be there for the next header will be 8 bits. Okay, so R is matching with 2. Now coming to the TCP header sequence number, you will have sequence number to identify each packet uniquely. So which is 32-bit information. Am I right or wrong? So matching for Q is matching for S is Q. So now let me check the each option. Option A is saying that P is 3, which is wrong. Option B is saying P is 2. Here itself I can say B is a wrong answer. Coming to the C, C is saying P is 4. Maybe chance that it is right. Q is saying 1. Okay. R is saying 2. Okay, correct. S is saying 3. So this is right answer. Now what is the problem with the D? We will check. P it is saying 4. Q it is saying 1. R it is saying 3. So that's why D is wrong. So what is the correct answer for this question? C is the correct answer for this question. So I hope you have understood how I solve these two questions. If you still have any doubts related to these two questions or related to the concept, anything which I discussed in this video, feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. If you really like the video, please press the like button, share the video with your friends, subscribe to my channel. Thank you for watching my video. Have a nice day.